Today we're going to be looking at the second part of the Instant JChem Developer Webinar Series. Part 1 was an overview of the IJC architecture and some preliminary introduction to API. But today is going to be pretty heavily focused on the Discovery Informatics Framework. So we'll look at that in terms of how it applies to some concepts. And then we'll start going through a lot of the API itself with some code examples to kind of show how DIF is interacting with IJC. So there will be a lot of programming snippets here, as well as how it applies to some of the concepts. But what I'd like to start out with is just a very quick review of DIF as it applies to Instant JChem architecture itself, for if you missed the first part of the series, or just so we can get a refresher on how these things fit together, which will really help make sense of the API itself when we get into it. So again, this is our IJC, our snazzy IJC architecture diagram. And the Discovery Informatics Framework here sits on a reasonably low level within the IJC programming itself as a separate API. And the DIF was the conceptualization of a relational model for scientific understanding for chemical and biological data. So this allows us to take an existing database infrastructure for a database, be it local or remote, and make sense of it in a chemical and biological fashion that allows us to do basically chemoinformatic work with it. So we mentioned previously that there were two major components to DIF. There is the DDL, which is the data definition language, and this is how the actual entities or the data tree are structured, how you connect to your schema, how a relationship is set up and organized, this kind of hierarchical architecture. However, if you want to actually do anything with the data itself, updating, inserting, analysis, whatever, then that happens through the data manipulation, the DML. So we'll be looking at those two things as separate separate entities. And there are also some very important concepts and principles that apply to DIF that don't necessarily fall within either of these. And we'll touch on that. At the end. The point here is to give you an idea of where to go for certain components of programming within IJC, and this really applies to a lot of the scripting work that you can do for extending Instant JChem. So everything you see today will be built upon for the scripting webinars at the end of April. And we'll also be assuming that there is some fundamental understanding of the DDL and the DML. And just to touch on our hierarchy again, very quickly, this is a review of how a data tree might be set up if we had an entity A, such as a structures entity, and an entity B, which could be an assays entity as a child, and they're connected via relationship. We have the entity A is actually an object, DF entity, and the relationship is an object as well. It's a DF relationship. And here is our child entity down here, which are connected via this relationship because this object, this DF relationship object, contains the information from the source and the destination fields and entities. And that's basically how this relationship is established, is with this information contained within the object. Anything that starts with a DF is obviously a DIF object. And this hierarchy is contained within a data tree. The data tree is just a container for the organization. It does not own the data itself or the entity themselves. So everything within Instant JChem is connected in a graphical theory type fashion. So we use terminology such as vertices and edges, which allow us to connect together objects. So we have a root vertex, which is also called the parent vertex, and the child vertex, or the detail vertex. And information always flows, quote, downhill in a data tree from the root vertex down. You can't access data from the child vertex up. So the data tree itself owns wrappers around these entities, which means we can have several data trees because you can have several wrappers around a single DF object. So in this data tree, we have the data tree.vertex as a wrapper around the entities, and the data tree.edge as a wrapper around the DF relationship. And the reason we have an edge wrapper around a relationship is that they can be organized in two different fashions. In this particular data tree, we see that the edge is following the same direction as the relationship. A goes to B in the relationship, and then the wrapper, which is the edge, follows the same direction because the edge goes from the entity, the parent, down to the child. So if we were to look at this in a programmatic fashion, down here, we're setting up our relationship direction. This is called the forward direction. This is because it matches the forward direction of the relationship itself. If we were to swap this around, like we looked at earlier today, or yesterday, depending on your time zone, we have entity B up at the top and entity A at the bottom, in which case the relationship, the black line relationship, went the other direction, because now it still goes from A to B, but the edge still went down, which became the reverse. And we'll touch on this again when we actually look at relationships and edges as diff objects. But now let's go and look a little bit more in detail at these objects themselves and some of the manipulation within diff. So as we have seen, you have a standard database table, which is just a DB table on your database side, and we can promote it up to an entity functionally. So we have a table with columns that can be turned into an entity with fields. Again, not all of the columns have to be fields, and an entity doesn't always have to be just a table. This happens to be the normal manifestation. And with an instant JChem, because of the diff modeling and the intelligence behind it, it then represents this exact same table as structures and Boolean fields or URLs or images or however. So DF entity is pretty much is one of the major components of diff and doing data manipulation within instant JChem. So we're talking about the DDL itself, which is again a structural component to the diff, not the data itself. So we're going to start by looking at DF entity. And DF entity again is just a model of a table or several tables joined together that contains one or more fields. It's just a data object. So we're going to show some code throughout this webinar, and it'll always be in purple and it'll always be in Java. But you're not stuck with Java. Our scripting webinars will actually be based in Groovy, which is a little friendlier for this setup. However, this is probably more familiar for developers across the board. So a field contains, an entity contains fields. So if we were to, let's say we wanted to get the fields from an entity, we're going to effectively get the fields, which is a container, and then list the items from our entity up here. And this is just a model for tabular data, and this would return a functional list of them. Now, everybody here, we're going to be doing a lot of get items, but when we look at some Groovy code, we won't be doing that because Groovy has a get set built-in functionality. So this may get a little hairy, but again, just remember that if I'm showing this without a get or set, you would need a get or set for Java itself. And within the entities are DF fields, which are, again, typically database columns, but they don't have to be. A DF field itself has an automatic data handling type. So it can handle different kinds of blobs or clogs. It knows how to process structural data. It knows it could recognize an image versus some other type of clob. We have built-in data types for chemistry and biology specifically. A DF field can also be a temporary memory-only field. It doesn't have to be a physical object, a physical column within a table. And a calculated field is something that you see within Instant JChem that has a little script attached to it that can do some sort of functionality, and then it just calculates that field on the fly. So within Instant JChem, it still acts like a real field. It's just a memory-only one. And the example that I provided yesterday in terms of how a field might be more than one column from a database is actually a pretty handy one. If we had, let's say you had a database table with 4 or 5 different assay values as different columns, assays 1, 2, 3, 4, and 5, and you didn't want to necessarily present 5 fields in your IJC table, what you can do is you can create a field which shows the range, in which you automatically detect the minimum and the maximum value from across these various database columns, and then in Instant JChem present it as a field with a single range. So it doesn't have to be a direct manifestation. So entities contain fields. Then we'll look at the data tree itself as the hierarchical component. So again, the data tree is just the arrangement of the entities and the parent-child data. And by parent-child data, we don't mean table data or actual database data. We just mean the organization of how the parent and child are set up. And it contains a set of vertices, which are the starting points for any edge, to the number of tables. So if you remember, a parent can have many children, so you could have several edges from one parent vertex. And even a child could have several children itself. So it's important to keep in mind that this could always be plural. And the vertex just has the connection information. Now the edge is the wrapper around the relationship object, and it represents the connection between the two entities. It has a source, it has a direction, and it has a destination. So down here we have a little snippet of code that looks at some of these things all together. If we have a data tree, so in this part we have fetched a list of all of our data trees that belong to our schema, and schema is the top level connection. And then what we want to do is get the root vertex of one particular data tree. Let's say we're working with one particular data tree, and we want to get the root vertex automatically. Let's just get root vertex. From the vertex, there is a method for determining the entity itself. So .getEntity will return our root entity. At that point, we can start doing entity manipulations via DDL now that we have our root vertex entity. You could also then list the edges from your root vertex, .getEdges to generate a list because it could be plural. And this is just a little iterative blurb down here that is showing you how to get the destination entity, or the destination, or this, you could also put it as the get source, would be the same thing. It's worth looking at in the API. But from a single edge object, you can determine sources and destinations automatically using just a reasonably simple method. So going up another level, up to the very top, is the DF schema, and this is the root object for all DDL objects. It represents a connection to a database. It's just an extension of JDBC, but it doesn't do anything to the database contents automatically, nor does it automatically connect. That's something that you have to do manually. However, this contains the information. It also contains all of the data trees, and because it's a hierarchical system, it also contains all of the entities, relationships, and all the DDL information downstream. So for this particular example, we're showing you how to get the entities from the schema, because the schema owns all the entities as well as all the data trees. The DS schema, as the top level, is the entry point for the data manipulation. So this is how the data is accessed from within the architectural components of the API. Again, I have to point out that a DF schema is not an Oracle schema. It can connect to an Oracle schema, but it doesn't have to be, and it is a functionally different setup than an Oracle schema. So whenever we refer to this in the training or in the documentation, I will call it either a DF schema or an IJC schema, just to try and keep things a little bit simpler. So what we're showing down here is the data access, is the entry point for the data manipulation, and this is via a data provider. And we'll look a little bit more at this in a few minutes. But basically, a data provider is just the DML object for accessing the data from whichever point you have. There are entity data providers and schema data providers. Again, we'll show this in a little bit more detail, but this is just showing the entry point from DDL into the DML. So we have a schema get data provider, and once we have our schema data provider, then we can start doing things with the actual resulting data, which is such as the default result set, or my entity data provider, or my relationship data provider. These are all parts of the schema data provider. But once you're in here, then you can start accessing data manipulation objects and classes. There also is, on the DDL level, DF relationship. which is, again, just an association between two fields and two entities. It can be a foreign key in a database, and this is the other interesting component, is that if you have an existing database that you're wanting to use in Instant JChem as opposed to building one in IJC, you can promote up an existing foreign key to be a relationship. In this way, ChemAxon Instant JChem can handle existing data relationships in relational database models. We've talked briefly about what kind of relationships we have. Basically, a DF relationship is a one-to-one or a one-to-many relationship, because a many-to-many is effectively a hidden join table that has its own database foreign key constraints upon it. Now, edges, which are the data tree wrappers around a relationship, are not created automatically, nor are they necessarily deleted. So if you're going to do anything with an edge itself, then you have to manually remove it or manually create it. So I have a couple examples down here of some of the methods that you can use with DF relationship. In this particular case, I'm wanting to get the relationships from the schema container in the list, so I'm just going to get relationships, get items. Now, if I wanted to look at the fields themselves and I wanted to determine what the source field is or what the destination field is, there are methods set in here. And if we looked at directionality last time, there was a forward and reverse direction, and this time we're just, for an example, saying get me the forward relationship. And now that I have that, get me the source field, and the same thing for the destination field, get the destination field. And once you have the related fields for that particular relationship, you can then use it to determine what the entity is. So we would say the source field, get the entity. At this point, I have now programmatically determined what my source entity is. Same thing goes for the destination entity. This is how I would programmatically get that object without having to hard code it. We also have user-owned items. These don't belong to the schema necessarily. They belong to the user itself. And these are the things, usually they are the temporary items that you can manipulate, like lists and queries. And if you remember in Instant JChem, you have the ability to create permanent lists and permanent queries. There also is an automatic saving of all your lists and queries in the temporary categories per user that get flushed when you log out. So DF query is just a container for the query criteria. You can save this temporary query as a permanent one in the future, but again, it is just a container for the criteria for that particular query. And you can call that by effectively getting the queries for the data tree, because queries are run on a data tree, and then get items, because those are my containers that get queries. The same ideology applies to DF list, which is just a list of any text or integer field. It's usually just an ID, which makes it easier to manipulate as opposed to a set of varchars or alphanumeric characters. And down here, we're fetching out our lists from the entity, because a list is applied to an entity. So the entity owns the container for our list. Two other user-owned objects are DF view, which we're all familiar with, is just the manifestation of a grid view or a form view. And this is just a model for representing those two different kinds of things. Or if there's any UI settings that need to be persisted, those are contained in the view themselves. So it's not the visual object, it's just a representation that is stored here. And it belongs to the data tree, again, so you can have several views on a single data tree. So we have data tree get views, get items. And DF script is another user-owned object. And this is, if you have data tree scripts or entity-based scripts, they all live in the DF script repository. And this can be a child of data tree or schema. So a DF script is just an object that contains the XML. It's not the script itself, it's the container. So this is a little squirrely. If we were to pull our scripts from our data tree, following the same kind of methodology, we have datatree.get scripts, get items. In order to actually return the script itself, I have to call a special method that gets the script XML content, because the XML is contained within another container within the script. So in this particular string, I am getting my scripts, and I'm getting the first item from my list, because it's returning a list. And then from that first item, which is going to be my container, my script container, I'm calling the get the script XML, and now show me the content itself within there. And this is all in the API, and I don't expect everyone to remember all of these things off the top of their head, but once you see it, you probably will recognize it when you run into it or you need it, and then you can easily find it within the documentation. So I made reference to a lot of container ownership items here, and this is how it all is set up. Everything from schema level down is effectively a DF item. So there's a lot of inherited behaviors and classes that everybody in the DF can utilize, and they come from DF item. DF schema has the container for, as to be expected, entity, DF relationship, and DF data tree. Obviously, schema script sits on DF schema level, and it's a user-owned item. And now the data tree itself can also contain DF view, DF query, or data tree scripts that belong to that particular data tree. And the entity, DF entity, contains the DF field definitions and the DF list. And the DF relationship is kind of the end of the line for him. There is no other containers here. So this chart is very important for finding API. If you need to find particular methods that don't necessarily, may not necessarily be contained within the subset itself, always check the master level container. And think about these things in a hierarchical fashion. What is it you actually want to do on which level? Is it something you need to do at the schematic level, or is it something you need to do more at the entity-based level? So that functionally covers a lot of the DML itself, DDL itself, sorry. And we'll be going on to look at some of the DML now, the data manipulation language itself. And this is used for manipulating data, which is usually considered just inserting, deleting, running queries themselves, because you're generating a result set or a data set and modifying values or updating. And the DML enters the schema via the schema get data provider, which is the root object for all DML operations. However, within that, there are two main classes that need consideration. One is the DF entity data provider, which is how you could control the data or manipulate the data itself on an entity. So each DF entity has its own entity data provider. 3 entities in your schema, you'll have 3 DF entity data providers. And the data is obtained directly from a data source, not a cache. So anytime you're querying data via the data entity provider, it's coming straight from the data source. And anytime you change the data within Instant JChem, either via GUI or programmatically, it's an immediate on commit. So down here we have just an example of how to get our entity data provider. And in all of our code sources, we will try to maintain some best practices across it. So we will always refer to an entity data provider as an EDP. So we get our data provider from the schema, and now I want to get my entity data provider from a particular entity, because the schema, this one schema, contains all my entities, thus it has all my entity data providers as well. The other one is the DF result set. Now, a result set is a little bit of a complicated concept, and functionally, what we have here, let's take a pause from the diff itself for a second and jump over and talk about result sets and vertex states themselves. So, if we have a standard data tree setup, here's our data tree within the green, where we have our parent vertex connected via an edge, which is wrapped around a relationship to a particular, my apologies, I was supposed to say child entity and child vertex here. And we run a query. We are going to have a particular set of data that gets returned. Now, a vertex state, remember this is a vertex, simply shows the setting of the data for this particular state. Let's say we run a query and we have a list of IDs as our result. Well, that list of IDs is now our vertex state, and this is just a snapshot. And each vertex has a resulting vertex state. Now, this is a little bit tricky because Instant JChem is currently set up to be able to have several vertex states at once, even though currently we can only have one. So when you run a query and you have a list of IDs that come back, that is your vertex state. However, the result set is a snapshot of all of this. The result set is a snapshot of both the parent vertex state and the child vertex state. However, everything is inherited from the parent. So our result set contains the IDs of the current selection or query result, but only for the parent, not the child. The child gets the IDs that are only related to the parent. So if I ran let's pretend that this is a structures and assays type setup, and I ran a query that returned a handful of IDs. My result set is just going to be the vertex state of the parent. It's just going to be the IDs of my structures. When I analyze this data, when I look at it in a form when I look at it in a form that also shows me the assay data, and I'm scrolling through my result set, I am scrolling through the parent IDs on the vertex state. And because of the relationship, I'm being shown the assay data for those IDs themselves. The vertex state does not keep the ID information for anybody downstream. It does not keep the child IDs. All it keeps is the parent IDs. But because of the relationship, it's then inherited automatically in terms of which rows of the child vertex are related to that particular query set. So the current result set is going to be functionally how we access the rows of the parent vertex. And views, a grid view or a form view, get their data from the result set. And this is how multiple views will be consistent, of course, grid view or form view on the same data tree, because it all takes its information from the same result set that keeps it consistent. So DF result set is basically a container for the DF vertex states, and the vertex state is what actually contains the data. But we have to access it all through the DF result set container. And we will look at that in a little bit more detail for down the line. But the idea here is that when you're accessing the data itself, you're not doing it on an entity level. You're using the entity data provider to look at the latest result set. And this will make hopefully more sense down the line when we start looking at scripting and coding itself. But this is good to be aware of, that this is how you're actually accessing query results on the fly. That is the vertex state. So now we're going to use this to look at some basic concepts and principles that are also very important for programming or scripting up within Instant JChem. And these are things such as locks. Now, obviously it makes sense to lock up a particular object if you're going to be manipulating it. You don't want anybody accessing an entity while you're changing the entity structure. So most diff write methods require a lock. And a lock is placed in the environment for the method. So every time we're going to run a diff write method and a lot of diff read methods, we have to create an environment in which to run these things. And the lock is then placed within that environmental context in order to run. So a lock is controlled via the interface df lockable, which provides a single object df lock at the same time. So this object, this df lock, is passed into the environment, at which point you'll use your diff method to do your operation, and then at the end you must release the lock to end at the end of the process and close the environment. And we'll talk about environments in a second. But there are several different lock types within one schema. So when you're locking something up, be it a schema or an entity or a user object, you're going to generate a different kind of df lock. We have a lot of methods for doing this. There are 4 different kinds of locking mechanisms, and we have a very good discussion on this within the API itself about df lock. And there are global DDL locking for shared objects. So you can, at the df schema, you can get a lockable, and this will lock up the df schema, entity, field, data tree, or relationship, everything that belongs within the df schema container itself. We also have a global DDL locking for user-owned objects. Get user lockable, and those are for user-owned DDL objects like df view, df query, and df list. You can also lock up entity data providers. for data modifications, if you're going to be editing the data as opposed to the structure, you want to use a DML lock. And this is, you would just get that lockable from your DF entity data provider, or the result set. Get result set, get lockable. So we have our DF result set, which contains the IDs of the actual current result, which could be the result of query, or it could be absolutely everything. And this would be for any property change or sorting or applying a query or a list, because you're changing the result set. If I'm applying a list to my, let's say, my entity, what I'm actually doing is I'm changing my result set. So it's not necessarily running a query and getting a result. It is the result of an operation. So if I apply a list, I have to change my result set so I see my listed items within Instant JChem itself, and I have just changed that. And if I wanted to view them all again, when you go to query show all, effectively I'm just changing the results again to show absolutely everything. So we put our locks into environments. An environment was created functionally to solve, there was a single thread diff method problem way back in the very beginning of the day with thread control. So by creating environments, now we can have things running in the background and we can pass variables back and forth. And an environment is just a holder for things like locks, as we mentioned. It requires a lock, but it also provides a holder for the feedback. And you can get feedback from a particular environmental operation using some of the get feedback methods, which are all contained within the DF feedback. And like we said with the locking on the the slide before, this holds a lock for a read-write operations. So you have either a read-write environment, a DF environment, DF environment RW, or a DF environment RO without a lock when it's not required, such as just reading data. You don't need to lock an entity or an entity data provider just to read data. You're not applying any relevant changes. DF environment RW is a sub-interface of the read-only environment. So effectively, you can start spawning read-write environments from one existing read-only environment, but you don't necessarily need to. You can create an environment, create a lock, run your method, release the lock, and release the environment functionally. And if you recall from the discussion of the API layering earlier today, or in part 1 of this webinar series, we pointed out in the commons, the IJC commons, that there was some environmental control methods. So what you're getting is your commons.progress env utils. This is where all of your environmental controls will live. So if we look at an example here of locking up an environment, creating locks and utilizing an environment, this little snippet of code is showing how to set the name of an entity. Now, since we're going to be changing the name of an entity, this is a structural modification, so we'll be using the DDL. Effectively here, we are just setting an action name, renaming entity. Now we're going to get our lock, and we're going to lock the schema, because that is what actually that contains the information of the entity. We're going to obtain our lock, and we're going to assign it a name. Now we're going to create our environment. And we're going to use our env utils just to create a default read-write environment. And the variables required here are the lock that we've created and the action name. And this is a cancelable variable, which in this case is false. So now we're saying, basically set name method of the entity and set it to whatever new name was that we want to, and do so in the read-write environment we've constructed. Now that we've done our one line of code and changed the name for our entity, we have to finish the feedback on the environment, which basically says we're done here, we're all done with the feedback, close out the object, we don't need it, and release the lock. And this, you need to put things in a try finally block. That way, if some of the code between the try finally gets goobered up, you aren't left with a locked up object, which is basically requires you to restart Instant JChem to release all of the locks automatically. So in conjunction with this, we've set the name for an entity. We've changed an entity. But if we wanted to create a new object, whatever it may be, a new entity, a new list, new view, programmatically, we're using something called df new type. And this is just an object which creates new items in its JChem based on the container it came from. And this is where our container flow it comes into play again, is that each container has a list of potential new types for each item. So df entity contains all the possibilities for the type of item that a list might be. So df item at the top level, which we don't have here, but everything here is a df item, has a df new type, and they all have a capability. So new types have particular capabilities which define what they are. And this is going to get a little complicated in the next slide to when we actually look at df capabilities. But in order to get around a lot of this, we've started creating helper methods in the API, which are df fields, not df field, but contained within df field, we now have methods called create text field. And this simply, you call this method for create text field on an entity, you give it a couple variables, and it creates a text field automatically, as opposed to having to determine the new type. So the old school method would say, I want to create, you would say, I want to create a new field. Well, you'd have to tell Instant JChem that it's a new type. Okay, great, so it's a new type of field. Well, Instant JChem needs to know what kind of field it is. So that's when you start putting together the df capabilities. And df capabilities, we have a slew of them. So just for as an example, if you wanted to create a new field, that a new text field in the old methodology before we created helper methods, you would have to specify it's a new field, it's a df field from the df new item, and it has the capability of df field text capability. Now I've indicated that I want to, on a particular entity, make a text field that has a text field capability. And you had to mix and match previously if it was a specialized type of field, which is why we have the helper methods now, that you can just pass over all of this for a handful of really commonly called mechanisms. This is an example of why we have switched over. So at the top, what we have here is how you would manually create a new field using df capabilities, and it's a little bit, it is rather complicated and a bit of a pickle in terms of calling new types and determining which capabilities you want, and then finally downstream creating it, versus the new mechanism in which we would just say, okay, I want to make a new field, so I'm going to create an integer field using this method. So from df fields, create an integer field on this particular entity, call its new integer field in Instant JChem. On the database side, call it all capitalized new integer field, and create it within whichever environment we have running it currently. And this is very simple. However, we don't have helper methods for absolutely everything. So if you're looking for helper methods in order to create any new kind of item or object within Instant JChem that doesn't have a helper method, then you have to go through the rather cumbersome new type methodology, at which point we just encourage you to contact us or work with us on this, as there are a lot of nested options that may need to be pointed out. However, we do have helper methods for the overwhelming majority of use cases, so hopefully that will make things a lot easier on there. So this was a very whiz-bang fast overview of the diff itself, and hopefully will give you a starting point of where to look for a particular API or how to go about navigating the hierarchy within Instant JChem to script up or to program. And when we look at when we go through the scripting webinar at the end of April, we'll be looking at these things in a lot more detail and providing lots of examples through functioning scripts on how we are accessing IJC, the various hierarchies, on the scripting level via the API. And we'll also be looking at some of the API itself. So in the meantime, as follow-ups, we do have some scattered documentation online, which is very detailed. You just have to navigate through it. We also have the public API, a lot of which is annotated with some examples and discussion. We are readily and quickly available via email for support and help. And we also have forums for discussion of these type of items. We also, in the consulting wing, do on-site trainings, 1 or 2 or 3 day trainings for developers or scripting or programming or custom work as well. So that wraps up this part of the webinar. And if you have any questions, now would be a great time to go ahead and ask them, or you're welcome to follow up with email or in the forums. So, Janusz, over to you.